Hello, everyone. Today we're going to talk about the query function in Google Sheets. It's a powerful tool for working with data, allowing you to filter, sort, and analyze data in a spreadsheet using queries similar to SQL. It's especially useful when dealing with large datasets, as it helps extract the necessary information quickly and efficiently. SQL, Structured Query Language, is a programming language that helps interact with databases. Imagine having a large table of data. With SQL, you can find the data you need, add new information, update records, or delete data. Simply put, SQL is like talking to a table, which represents a database, telling it what to do, and the table executes your command. The query function in Google Sheets works very similarly to SQL, but in a spreadsheet format. It uses the Google Visualization API query language, which extracts and analyzes data from Google Sheets. It has similar commands, such as select, where, to SQL. All calculations and filtering happen on Google's servers, not in Google Sheets itself, which speeds up the process. When you use Query, Google Sheets sends the request to the Google Visualization API, which processes the data and returns the results. This allows you to work with large datasets more quickly and efficiently. You can think of the API as a handle you pull to access the server and retrieve the data you need. For example, imagine pulling the handle of a classroom door, where a teacher checks the gradebook and provides you with a list of students who got good grades. You don't need to flip through the entire gradebook manually. The teacher does it for you. Similarly, Google API handles all the hard work in the background, and you just get the results. Query can filter, sort, group, and aggregate data all in a single query. Optimized algorithms used in Query and Google Visualization API allow for processing large datasets much faster than standard formulas in Google Sheets. When working with large datasets, Query uses indexes to locate specific rows and columns quickly. Unlike filter or sort, which process all data row by row, indexes allow you to jump directly to the required part of the data. Imagine having a book with an alphabetical index. You can quickly find the right page instead of flipping through the entire book. Query also uses data compression and caching to store intermediate results. For repeated queries with the same data, results can be retrieved from the cache, which significantly reduces execution time. Repeated queries are processed instantly because the data doesn't need to be recalculated. This is especially useful when analyzing large tables with constant data. It's like when you frequently search for the same thing online, your browser caches the pages so they load faster next time. Query can split data into parts and process them in parallel across multiple servers. Parallel processing allows large datasets to be processed faster. Imagine assigning 10 tasks to different students in a class. Each one completes their part simultaneously rather than one by one. Let's move on to Google Sheets and take a look at how the query function works. The function has two required arguments, data and query, and one optional argument, headers, data. This is the data range you're querying. It's the range of cells where the query is applied. Each column can contain only Boolean values, true or false, numbers, including dates and times, text, strings, query. This is the actual query written in Google Visualization API query language. Headers. This is the number of header rows. It's a number indicating how many rows in the data range contain headers. 0. No headers. Data starts from the first row. 1. The first row contains headers. 2. Two header rows, and so on. If headers is omitted or set to -1, Google Sheets tries to guess how many rows are headers based on the content. The following keywords, clauses, are used to create queries. Select, selects columns. specifies which columns to return and in what order. If select is omitted, all columns are returned in their original order. Where filters data, returns only rows that meet certain conditions. Group by groups data, aggregates values by specified columns. Pivot pivots data, transposes rows into columns. Order by sorts data. By default, it sorts in ascending order ASC, but you can use DESC for descending order. Limit limits the number of rows returned. Offset skips a specified number of rows before returning data. If limit is used, offset is applied first. For example, limit 15, offset 30 returns rows from 31 to 45. Label renames columns. Format formats data by applying specific formats to column values. Aggregation and scalar functions are also used in queries. Aggregation functions perform operations on groups of data. Examples: sum of values, count, number of rows, AVG, average value, max, maximum value, min, minimum value. Scalar functions work with individual values and return a new result. Examples: year extracts the year from a date. Month returns the month number. Day returns the day. Upper converts text to uppercase. Lower converts text to lowercase. DATEDIFF, difference between two dates. Now returns the current date and time. You can also use arithmetic operators and date and time literals. Arithmetic operators perform mathematical operations. For example, plus, addition, subtraction, multiplication, division, date and time. Literals used for specifying date, time, and date-time formats. Examples: date 2008-3-18, time of day 12:30:45, date time 2008-3-18, 12:30:45. When writing a query, it's crucial to specify where to get the data correctly. You can either use column letters from Google Sheets, for example, A, B, or use col2, col3, and so on. You cannot use custom column names. For example, if you name a column price in the first row, you'll need to write A or col1, not price. It's worth mentioning Smart Tables in Google Sheets. They provide a modern visual interface, restructuring data directly in the browser. They allow you to filter, sort, group, and add calculated fields intuitively without manually writing formulas. Query and Smart Tables complement each other rather than exclude each other. If you have simple tasks, Smart Tables are convenient. For complex and automated scenarios, Query is the better tool. Smart Tables are great for users who prefer to visually configure data without diving into formulas. We have an order table. It contains order numbers, customer names, the products they ordered, and their categories: quantity, price, order date, delivery date, region, and sales manager. First example. We want to get a list of all orders from the tech category made after March 1st, 2025. First, we select the table we are going to work with by highlighting it. Then, we specify the columns we want to include in the new table using the select keyword. Next, we specify the condition to display only the tech category and dates after March 1st, 2025. Pressing Enter gives us the desired result. We can double-check the original table to confirm this is correct. As we can see, only one order from the tech category was placed after this date. In this case, you used Select to choose columns, where to apply a condition, and to combine two conditions, equality and greater than signs, and a date condition. Now, let's look at using group by and sum. Suppose we need to group sales by region and calculate the total revenue. Select the table. Specify the column with the region. Use sum on the total column and group by region. Now we have a new table where the total revenue is displayed for each region. Next scenario, counting the number of orders by month with a breakdown by categories. Select the table. Extract the month from the date. Count the number of order IDs, group by month, and use pivot to rearrange categories into table headers columns. The month function returns the month value, starting from 0, from a date or date time value. Since months are counted from 0, the function returns 0 for January, 1 for February, and so on. Now let's talk about order by, limit, and offset. Suppose we need to display the top 3 most expensive products, starting from the second most expensive. Select the table. Specify the order number, customer name, product, and price columns. Sort by column F, price, in descending order so that the highest price appears at the top. Specify that we want only 3 items, our limit, and use offset to skip the first, most expensive item. As we can see, everything works correctly. We can double-check by looking at the original table. Now let's explore label and format. We need to calculate the average price by category and rename the columns. Select the table. Select column D with the category. Calculate the average price from column F. Group by category and assign a new name product category using label and average price to the average price column. Then, apply a format to display the average price in dollar format. Let's now see how max and min work. Suppose we need to find the maximum and minimum price of products in the furniture category. Select the original table. Get the maximum and minimum values from column F, price. Add a condition that column D, category, should be furniture. Press Enter, and we get the result. As we can see, the maximum price is $900, and the minimum price is $150. Now, let's explore scalar functions like year, month, and day. Suppose we want to show the order ID and the year, month, and day of the delivery date. Select the original table. Select the columns we need in the new table. This will be column A with the order ID and column I with the delivery date. We use scalar functions to get 3 new columns with the year, month, and day of delivery. In Query, Google Sheets uses a month numbering system from 0 to 11. Similar to JavaScript and some other programming languages, we can fix this by simply adding 1 to the month. Let's do this now. Now we have the correct month number, which is more intuitive for users. Let's see how upper and lower work. We will display customer names in uppercase and region names in lowercase. Select the original table. Select column B with customer names and apply upper. Select column J with regions and apply lower. Press Enter to get the result. Continuing with dates, let's explore DATEDIFF and now. We will calculate how many days have passed from the order date to today's date. Select the original table. Specify the column with the order ID. Use DATEDIFF to calculate the difference between today's date and the order date from column H. Assign a name to the new column using label. Let's call it Days Since Order. Now, let's look at arithmetic operations in query. We will display the order ID, quantity, price, total order amount, and a 10% discount on the total amount. Select the original table. Select columns with order ID, quantity, and price. Create a new column where the price is multiplied by the quantity and name it Total using label. Create another column where the price is multiplied by the quantity and 0.9, and name it with 10% discount. Press Enter and get the required data quickly. That's it. The query function is a powerful tool that allows you to process and analyze data in Google Sheets efficiently. With its SQL-like syntax and Google API's optimized algorithms, you can handle large datasets quickly. Query is great for automating data processing, while Smart Tables provide a user-friendly interface for simpler tasks. Together, they offer flexibility and efficiency for various data management scenarios. Now that you're familiar with query, it's time to put your knowledge into practice. Let's dive into Google Sheets and try creating some powerful queries yourself.